And so if we start with the electron, now we know the electron has got mass, and we know the electron has got a negative charge. So it's got a negative charge and it's got mass. And so this electron, the electron, you also got something called a positron, which is the opposite of an electron, which has got a positive charge. And so for every action, there's an opposite reaction. For every something that exists, there's an opposite thing that exists. But don't go and worry about all this fancy physics. Let's just look at the electron. Now, the thing is, normally when they tell you about the electron in electricity environments, they normally say to you, well, here's the electron, it's got a negative charge, and it's a charge carrier, and this electrons, which is what is flowing in the conductor, and this is what gives you your current flow. And so they might tell you about something about electron drift, and then they will say to you that these electrons are attracted by the positive and it is repelled by the negative. And then you can get an idea that when you've got all these negative electric charges, that if you've got this negative electric charge, you're going to have some electric field which can be associated with this negative charge. And so you would very easily say that a positive charge and a positive charge repels one another, and a negative charge and a negative charge repels one another. And a positive charge attracts a negative charge, and a negative charge attracts a positive charge. So those little things there you can show a child very easily, and they can get an idea just by going to look at magnets, where a north and a north repel, and a south repels, and a north and a south attracts, and a south and a north attracts one another. So you can very show this physically to a child. Now, there's one thing which they never told you about the electron, and it's something also which always bothered me. I mean, we can imagine this current flowing through the conductor, there it goes, and then we can see the charge flowing and the current flowing, and from there we can now see there's negative charge, and you can see now for the negative charge, you're getting the fields and so on. But now, how does this magnetic field form around the conductor? And where does that magnetic field come from, you know? And then they say, no, but it's there, and they show it to you with iron filings and all these wonderful things. But you say, yeah, that's fine. But now, where is it coming from? The problem is that they never tell you that the electron has got spin, and that the electron has got a north pole and a south pole. Now, when you put these electrons freely into a conductor, they repel one another, okay? But then they turn and they actually form little north, south, north, south, north, south, north, south, north, south, north, south field lines. And those little field lines are then outside the conductor as well. And you can see the actual, how the field is then formed by these little magnets aligning inside the conductor. And these little magnets, as they align in the conductor, the similar propel and the opposite attract, and they get a state where they go into. So now what happens is that to form the field around the conductor, when these start moving and they become free to move, and these little magnets start attracting to one another, then cluck, 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 they form those field lines. And because they're negative in charge, they repel one another negatively, but they also attract in different directions one another, you know, attract one another with the little magnets. And so you find that it forms a type of a flow of charge with a magnetic field around it, but also an electric field around it. And that is how you basically then get this field around the conductor. But now, if this conductor is sitting there, and this conductor that's sitting there has actually now got free electrons, and it's all sitting freely there, but now how do we get them to move? That was another thing. How can you get a magnet, take the conductor and move it across a magnet, or take the magnet and move the conductor and then get these electrons to move? But this is something that's got a charge. Now, how does the magnet move this something with a charge? Because it's a little magnet as well, it's quite easy. Because now when you bring the magnet here and you move it across the conductor, you're taking these little magnets here, they will come. If that is a north pole, you got here, this little south pole will follow that north pole. And so you can get, by moving the magnet across the wire, you can get electrons moving because you're moving these little magnets with the other magnet. Now it makes sense. Eureka, I can now see what is actually getting these electrons to move. Now you see if we fix the magnets and we now take the conductors and we spin the conductor through the magnetic field. Now what happens is that we will move these little magnets, which will move the charge on the inside. We get charge movement, we get current flow, we've got a generator running. And again, in the opposite, we can explain the motor effect, everything with that. So basic electricity 101, it's all got to do that you must not think of the magnet as just a negative charge. You must think of the electron as a negative charge. You must think about it that it's got spin and it's got a little magnet, and that there you can explain to any person in very simplistic terms with very easy experiments to show it why you have the generating and motor and electromagnetic fields and so on, where it comes from.